Alright, welcome back Year 12. Today we're going to be looking at Module 6, Electromagnetism, Inquiry Question 4, which is the application of the motor effect. To be more exact, we are analysing the operation of a induction motor and a AC motor. In the next recording we'll look at the difference between a DC and AC generator. So firstly, if we look at motors, we can break it into two types. We can look at the DC motor or the AC motor. Obviously, DC we talked about before. That is using direct current and you need a split ring commutator for it. An AC motor, okay, because it's alternating current, the current shifts direction for every half rotation that is occurring. We don't use a split ring commutator, we use a thing called a slip ring commutator, which I'll allude to a little bit later on. So DC motor, in terms of how it works, remember there's two main parts, the stator, which is your stationary magnet, and then the rotor, which is your rotating coil, and it kind of just rotates along. The reason why the DC motor rotates is because the current carrying charges in our coil will interact with the external magnetic field, causing the motor effect to occur. So there will be a force that's exerted on one side of the wire and another force being exerted on the other side. And that imbalance between the two causes some kind of rotation. It also uses a split ring commutator, which is there to ensure that there is a connection and disconnection for every half rotation that's occurring. So the wire will have a different direction current going into it or out of it to ensure we have a torque that continues to rotate in the same direction. If we look at a simple AC motor, it essentially has the exact same structure as a DC motor, besides one feature, and that feature is this slip ring commutator. Okay, so that's the only thing that's different. The reason being is the function of the slip ring commutator is just so, because the current is already moving in opposite directions every half rotation, so it could go in this direction here in the first rotation, and then in the second rotation, in my second rotation, it goes back the other way. And as we know, that's the way it will keep our motor rotating in the same direction. Let's just assume it rotates in this direction. We're trying to encourage this kind of motion here. Okay, the next thing we're looking at is so to keep it cool, we also use a ferromagnetic iron core. So this is our iron core here, so that's the core. Okay, all our axial, the axial plus the rotating coil, that becomes the armature. So the armature is using the axle here and the coil to make our little armature. Okay, the other thing we need to look at is with an AC motor, it's powered at exactly 50 Hertz, which means the current will reverse 50 times in 1 second. Okay, that goes back to our understanding of frequency and period. So frequency is over 1 over t. Okay, so the time it takes for one oscillation is 1 over 50. So about every 0.02 seconds, the current will reverse on itself. So when this coil moves the other direction, it will reverse, and that's how you get that motor rotating in the same direction. The next thing we have is with AC motors, they actually need a thing called a kickstart. Essentially what that means is, if you think about it, if you have a motor and the current is kind of moving in here and then moves out, and then next rotation goes in the opposite direction. What tends to happen at the start, if you're just left with simple AC, our AC current doesn't have a strong enough starting torque. So it kind of vibrates on itself. It doesn't have a strong enough starting torque to start rotating on itself. And so to help it rotate and accelerate at the start, there's usually a separate DC supply that's added into the rotor first. Once the rotor starts rotating, we try and match it back up with a AC signal, and so that will induce a field in the coils and the magnet will keep the rotor going. Okay, so that's how we try and ensure the AC circuit starts rotating. We start it with a DC source. Once it starts rotating, we change it to AC. So this is the next bit, which is the AC induction motor. Remember, AC induction motor is different from an AC motor. The main difference is, in an induction motor, there won't be any commutators attached. So in an AC motor, there are commutators. In an AC